Hi students, so in this video I'm going to solve a problem in which a solid bronze cannon with mass 560 kilograms is being recovered from a shipwreck and is suspended by a lifting cable. The density of bronze is 8,900 kg per meter cubed and the density of seawater is 1025 kg per meter cubed. Now you have to calculate the tension in the lifting cable when it is suspending the fully submerged cannon, and also calculate the tension in the cable as the cannon leaves the water and when it is held with a third of its volume still submerged. How do you go about solving this problem? So in order to solve this problem, I'm going to draw a visual aid. So imagine here you got a big tank with some water in it. So that's the water level, and you have your cannon. Yeah, that's the front end of the cannon. Now as I draw it again. Now as I lower the cannon in my tank of water, and say the cannon sits at the bottom of the tank now, what is going to happen to the level of this water? That level of water will rise by a certain amount. Say it rises by this amount. See, the water level has risen. Now this is Archimedes' principle, and basically whenever you have any object being immersed in a liquid, it displaces a certain amount of water. Now imagine you have the tank, this cannon being removed out of the water with say the help of a crane, and I'm going to draw that situation here. So that's my tank of water, and my cannon is say being picked out of the water now. That's my cannon, and it is being lifted with the help of a cable. See, that's the crane lifting it. The water level will be the same because the cannon is still fully submerged in the liquid. Now instead of seawater, we are just lifting the cannon from a tank, which is basically the same concept. Whenever you're lifting the cannon from water, this cannon will displace some amount of water here. Okay, so keep that in mind. Now calculate the tension in the lifting cable. So this is the lifting cable lifting the cannon up. You got to calculate the tension in the lifting cable when it is suspending the fully submerged cannon. So this is the situation. How do you go about doing that? Now in order to find the tension in this cable, that tension is going to be equal to the weight of the cannon. So I'm going to write this down. These formulae that I'm going to write down are not there in your formula sheet, so you'll have to memorize these. Tension in cable will be equal to the weight of cannon minus upthrust felt by cannon due to water. So whenever you have any object immersed in water, Archimedes said that this object will feel a upthrust or the buoyant force. Now this buoyant force is equal to the weight of the volume displaced, weight of the volume of the water displaced by the object. So first of all, we got to calculate the weight of the cannon, which is already given to us. So let us write the given data first. Weight of cannon is equal to 560 kilograms. Upthrust felt by the cannon due to the water. So I'm going to say force up, that's the upthrust felt by the cannon, so I'm going to name it as force upthrust. This is going to be equal to the weight of the volume of water displaced by weight of the volume of the water displaced by the cannon. Now how do you find the weight of the volume of the water displaced by the cannon? So this is the amount of water which will be displaced when the cannon is fully submerged. So we got to find the weight of this liquid here which is being displaced, or liquid or water which is the liquid in this case here displaced. So how do you go about finding the, so for that we need to find the volume of the cannon. Now volume of the cannon is what we got to find. How do you find the volume? So you see, we have the density of the bronze, or basically the material of which the cannon is made up of, and that is 8,900 kg per meter cube. And we also have the mass of the cannon. Now density is equal to the mass over volume. This formula here is not there in your formula book, so you will have to memorize this. Mass over volume. So we have the density, which is 8,900. We have to calculate the volume, and we have the mass available. So let me make a note of the given data. So I'm going to make a note of it here. Density of water is 1025 kg per meter cube. Density of cannon is 8900 kg per meter cube. Mass of cannon, M cannon, is 560 kilograms. Do we have any more information? No, we don't. Right. So we have to find the volume of cannon. So V, or volume of cannon, question mark. So we use this equation, density equals to mass of cannon over volume of cannon, and hence volume of cannon will be equal to mass of cannon over density of cannon again what we have done here is basically we have used transposition, where we took the volume on the other side of the equal to sign. And because this was divided by, it goes on in the numerator of the other side of the equal to. And because this density here is on the top, and it is it's kind of like multiplied by 1, it goes in the bottom. So that's transposition. Now we have here, do we have the mass of the cannon? Yes, we do. So that's 560 over, what is the density of the cannon? 8,900 kg per meter cubed. So 8900. So I'm going to get my calculator out now, and 560 divided by 8900 will be equal to 0.0629 or 0.063. So volume of cannon will be equals to 0.063 meter cubed. Now that we have the volume of the cannon, we can now find this volume. This volume of the cannon will be equal to the volume of the liquid displaced. So volume of liquid or water displaced, I'm going to write water, will be equal to volume of cannon, which again is equal to 0.063 meter cube. Now we have to calculate the tension in the lifting cable when it is submerged, when it is suspending the fully submerged cannon. So we got the volume. The upthrust felt by the cannon when it is being lifted here will be equal to the weight of the liquid displaced, or mass of the liquid displaced. So mass of liquid or water displaced will be the upthrust felt by the cannon. Now again, we need to find the mass of this water displaced. So again, we are going to use our density equals to mass over volume formula. Density of water will be equal to mass of water over volume of water. Now this volume of water is basically the volume of liquid displaced. Okay, so don't get confused. I'm going to name it volume of, I'm going to name this as volume water. It's the same. So now, do we have the density of water? Yes, we do. I'm going to rearrange this equation first. I want to find the mass of the water. So I'm going to take the volume of the water on the other side of the equation. So density water times volume of water will be mass of water. So what is my density? Density is 1025 kg per meter cubed. So 1025 times my volume of water, which is equal to 0.063. 0.063. That's going to be equal to my mass of water, which is going to be equal to 1025 times 0.06. It's 0.063. 1025 times 0.063, that is going to be equal to 64.57. 64.57 kilograms will be the mass of water. So now the tension in the cable will be weight of the cannon minus upthrust felt by the cannon due to water, which is the same as mass of the water. Okay, so tension in cable, I'm going to write T cable will be equal to weight of cannon, that is W cannon, minus mass of or weight of the water or mass of the water. Actually, I'll make this mass of cannon. Mass is the same as weight, M cannon minus M water, which is going to be equal to, mass of my cannon is 560 kilograms minus my mass of the water is 64.57 kilograms, and that's going to be equal to 560 minus 64.57 in decimal, 495.48 kg. Now this is the upthrust, this is the tension in the cable when it is being suspended by when the cannon is fully suspended in the water. Now we got to calculate the B part, that is calculate the tension in the cable as the cannon leaves the water when it is held with a third of its volume still submerged. So we got a third situation here. And in this case, my cannon is somewhere over here. Draw my cannon. I know it's getting a bit bigger in my diagram, but then I assure you it is not. So it's just my diagram. And it is about a third in water. What you see has happened here is, as my cannon is being raised, the water level goes down. Only a third of this cannon is submerged in the water over here. So volume of the cannon which is submerged is only a third. Only a third of it is in water. So what is going to happen is the upthrust felt by the cannon, which it was feeling because of the buoyant force, will again go down. By how much? It's going to go down by a third. We're going to do that in the calculations here. So this is my A part. I'm going to write it down. So A part here, A, and A, which is tension in the cable, is 495.48. So for my B part, page turned over, let me make a note of the B part. Calculate the tension in the cable as the cannon leaves the water and it is being held with a third of its volume still submerged. What is going to happen here, what it means is, now here we have the volume of the liquid displaced, which is 0.063 meter cubed. So what is when you have only a third of the cannon sticking in the water, this volume will be going down by a third. So I'm going to write it down again. Calculate the tension when only 1/3 is submerged. So my original volume of water displaced was equal to 0.063 meter cube. That's the volume of cannon. So volume when only a third of the cannon is sticking in the water will be equal to a third times my volume 0.63 of the cannon. That is going to be equal to, get my calculator out, so 1 divided by 3 times 0.063. Let me check my values. Yes, it is 0.063. That's going to be equal to 0.021. 0.021 meter cube. Now again we have to calculate the mass of this volume. So because if I take a look at my problem that I solved previously, mass of the liquid displaced will be the upthrust felt by the cannon. Now this time the mass of the liquid will go down by a third because only a third of the cannon is still sticking in the water. So mass of water displaced so now again I'm going to use the same calculations here. So initially my mass of the water, so density of water times volume of the water which is being displaced will be the mass of the water. So density of water times volume of water will be mass of water. Density of the water stays the same, which is 1025. Volume of the water this time has reduced because only a third of the volume is being displaced. You see, that's the original level of water. This is the level of water when the whole cannon is submerged. But now because the cannon is just 1/3 submerged, the volume displaced will be a third, which we just calculated here. 0.021. That's going to be mass of water. Again I get my calculator out. 0.021 times 1025 will be equal to 21.52 or 53. 21.53 kilograms. Now this time, because only a third of the cannon is sticking in the water, the upthrust felt by the cannon will be less. Before it felt an upthrust of 64.57 kilograms when the whole cannon was submerged. Now that the cannon is being pulled out, the buoyant force also goes down because the volume displaced by the cannon goes down. And hence, when only a third of the cannon is sticking out, it's going to get an upthrust of only 21.53 kilos. So again, tension in the cable will be equal to the mass of cannon minus mass of water displaced. So my mass of the cannon is 560 kilograms minus mass of the water displaced with only a third of the volume is 21.53 kilograms. And hence that is going to be equal to will be 560 minus 21.53, 538.47 kilograms. That's my B part calculated. It's a good practice to highlight your answer so that the examiner can find your answer with ease and you will not lose problems. That's my B part solved. And if I turn my page over, that's my A part solved. Now what I want you to do is stop this video, make a note of this problem and try to solve it by yourself without looking at the video. Now you don't need to write all of this because when you're solving this question in the exams, you got to use as little steps as possible. I only wrote all these steps so that you understand the problem. So as long as you write the given data and basic equations, that is going to be enough to get you full marks. Please note that this formula here is important, that is density equals to mass over volume, and you have to memorize this formula. So good luck with solving the problem, and now you try it. Good luck.